am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this November 2025 lecture series, we are discussing about biomedical signal processing concepts and applications. And today, we are going to discuss about wavelet analysis in time frequency and multivariate analysis. First of all, why wavelets matters in biosignal processing? Actually, we need time, frequency, power, and transient capture for signals, and this should have impact in clinical support. Here are wavelets. It provides simultaneous time and frequency analysis and perfectly suited for non-stationary biomedical signals like ECG, EEG, and EMG. And unlike Fourier transforms, wavelets excel in capturing brief, transient features of accurate diagnosis and detecting anomalies in signals. And the clinical impact, like a discrete wavelet transform, it enhances ECG signal diagnosing and feature extraction, and also it enables detection of cardiac disorders and arrhythmias easily. Okay, first of all, we have to understand our empathy, understanding user and signal needs. Here, our users' key insights includes cardiologists need a real-time, nice, robust ECG analysis during critical patient monitoring, and technicians they are struggle with motion artifacts that obscure genuine physiological signals. And emergency physicians they require instant, reliable interpretations, and researchers they need a reproducible analysis methods. Here our empathy reveals us clinical workflows they demand algorithms that balance sensitivity with specificity while operating in challenging real world conditions. See here, our aim is framing the problem with precision. This is our core challenges. How we can extract meaningful noise-free features from complex biosignals that should enable accurate, timely diagnosis while maintaining clinical usability. And for example, improve the detection of EEG abnormalities in epilepsy patients using advanced wavelet based signal processing, which is reducing the false negatives by 30%. And our impact is a clear problem definition directly guides critical decisions based on wavelet family selection and algorithm architecture. See here, first, we have to choose a perfect wavelet family for better accuracy and precision. And we may also incorporate hybrid approaches. For example, we can combine convolutional neural networks with wavelet derived features and multi-resolution analysis. Explore the orthonormal wavelets for decomposing signals into multiple resolution levels. See here, we have to build our wavelet based tools for that. First one, environment development, and then core modules and real applications. For example, we have to build comprehensive toolboxes in MATLAB or Python for continuous wavelet transforms with a clinical grade precision. And core modules, the prototype which includes adaptive noise filtering, automated feature extraction, and intuitive visualization modules. Real applications, for example, we have wavelet based EMG sensing interface prototype, and the accuracy is increased up to 94%, like that. First thing, we have to build our wavelet based tools for real time problem, for finding real solutions to real time problems. And our foremost thing is validating the real biomedical data. This is our main thing. Here, the performance metrics includes our signal to noise ratio and classification accuracy, computational efficiency and latency, clinical sensitivity and specificity, and robustness across patient demographs. Here, our breakthrough result, which states that a multimodal deep learning with wavelet pre-processing, it improves the EEG and ECG classification accuracy by 16% compared to traditional methods. So we go with wavelets in signal processing. See here, Wavelet analysis impact. Here are real world applications which includes cardiac monitoring, neurological diagnostics and rehabilitation technology. Here in this topic, I have included one in-class activity, wavelet family identification. Here the objective is differentiate between common wavelet families and their uses for better understanding. Here are comprehensive summary which includes a design cycle based on RDT approach and wavelet concepts, applications and tools and outcomes with the help of MATLAB Python. See, here our assessment part, an imaging equipment manufacturer like MRI or CT scanner uses vibration sensor to predict component wear and tear. Here the question is, discuss how wavelet based vibration analysis can support predictive maintenance in medical imaging system. And also I've included some reference links for wavelet analysis in signal processing. Kindly go through it. Thank you for watching.